Property 1 square numbers will always end with the digits 0, 1, 4, 5, 6, and 9. For example, 9, 14, 25, 81, 100 are perfect squares, whereas numbers like 17, 22, 83 are not perfect numbers. Property 2, a square number always contains an even number of zeros at the end, and numbers containing an odd number of zeros cannot be square numbers. For example, 1, 600, 3, 600, 2, 500 square numbers, whereas 1,000,
250,160 are not square numbers. Property 3, a number containing 1 or 9 is the last digit will always have 1 at the end of its square number. For example, the square number of 9 is 81 and 11 is 121. Property 4, a number that has 4 or 6 as the last digit will have a square number ending with 6. For example, the square root of 4 is 16 and the square of 16 is 256. Property 5, the square of an odd number is always odd and the square of an even number is always the reason. For example, the square of 15 is 125 and the square of 22 is 484. Property 6, square numbers a positive as two negative signs multiplied by each other result in a positive sign. For example, 5 times minus 5 is equal to 25. Property 7, square root of a square number is a whole number. For example, the square root of 441 is 21, so your 441 is a square number. If the square of a number is a decimal of a fraction number, then the number is not a perfect square. For example, square root 56 equals 7.48, so your 56 is not a perfect square. Property 8, for every natural number n plus 1, superscript 2 and superscript 2 sat base n plus 1, plus n. Property 9, the sum of the first n odd natural numbers is equal to the square of a number n. 1 superscript 2 equals 1, 2 superscript 2 equals 1 plus 3, 3 superscript 2 equals 1 plus 3 plus 5, for superscript 2 equals 1 plus 3 plus 5 plus 7, and so on. Property 10, for any natural number m greater than 1, 2m m superscript 2 dash 1 em superscript 2 plus 1 is a Pythagorean trip.
In this video, I'm going to cover what are square roots. Now, when we're looking for the square root of a given number, we need to think about what number multiplied by itself gives us that given number. That may not make any sense now, but after our examples, you'll see exactly what I mean. So let's jump into number 1, where we have a 3 and a 9. Before we talk about square roots, let's talk about squaring a number. Squaring a number means we have an exponent of 2. That means we multiply the number by itself. For example, 3 squared means 3 times 3. So let's do this. 3 squared means 3 times 3, which gives us 9, right? 3 squared equals 9. Now let's start with that 9 and do the opposite or inverse of squaring a number. And that's going to be taking the square root. So let's start with 9 and take the square root. So that's going to give us, well, the square root of 9. Let's think about what number multiplied by itself will equal the number under the square root symbol. This is the square root symbol there, also known as the root symbol or radical symbol. Well, we know 3 times 3 equals 9, so the square root of 9 is 3. Think about it. We know 3 times 3 equals 9. So a number times itself equals the number under the square root symbol. So the square root of 9 equals 3. Let's move on to number 2 and try another one. So 5 squared, 5 times 5 equals 25. Let's start with 25 and take the square root. So the square root of 25. What number times itself equals 25? Well, we know 5 times 5 equals 25, so the square root of 25 equals 5. 5 times 5 equals 25. A number times itself gives us the number under the square root symbol. So again, the square root of 25 equals 5. Let's move on to numbers 3 and 4, and we're just going to take the square root of these numbers. So for number 3, we have the square root of 4. Well, we know 2 times 2 equals 4. 2 times 2 equals 4. A number times itself equals the number under the square root symbol. So the square root of 4 equals 2. That's our final answer. And lastly, number 4, we have the square root of 36. Well, we know 6 times 6 equals 36. A number times itself equals the number under the square root symbol. So the square root of 36 equals 6. So there you have it. There are some examples of square roots and a basic explanation. I hope that helped.